Right. So start with some interesting questions today, which are mainly based on relative motion along a straight line. So based on that, we will discuss some interesting type of questions today. So let's start with this. So all these questions can be solved by basic equations that you have seen in 9th and 10th, including the motion along a straight line with uniform acceleration and those kind of things. Okay. So let's start with some examples on what we call relative motion. Of course, in so here's an example for all of you. We have and there is a person inside it. Let us say this is person E, and this elevator is descending at uniform acceleration. So this is elevator descending at a uniform acceleration. Also, you can see my diagram is considerably tall compared to the person height also. So you can think of it like a freight elevator or something like that. Okay. So now what happens is, while Bhavik, if the voice is can be an issue with your internet connection, so please everything is fine from my end, I can assure you. Yeah. So while the elevator is descending, what happens is comes off the ceiling and falls to the floor. Okay. So given that the acceleration of the elevator A0 was 4 meters per second square, and the acceleration due to gravity is 10 meters per second square, and the height of the elevator is 6 meters. I told you it's a pretty tall elevator. It is something like a freight elevator. So the height is unusually tall, something like so the height is unusually tall, something like a freight elevator, so something like 18 feet it is almost, okay, 6 meters. Right? So given that situation now we have to find the time taken for the screw to fall to the floor, okay, starting from the ceiling. So that is the first part we have to calculate. And the second thing we want to calculate is if the velocity of the elevator was 2 meters per second at the instant when the screw comes off the ceiling. Find its displacement with respect to ground. Okay. during the time it falls from ceiling to floor. So let me just minimize that for you and explain the question again. Yeah, to answer one of you people in the messages, you don't need the height of the duct, okay, because see what is happening here is that the screw is coming off from here, okay, and then it is falling and reaching the ground. So don't worry about the duct of the elevator. It is long enough that the elevator is throughout this part when the screw is falling, throughout that duration of time, the elevator is in continuous downward motion with a uniform acceleration E naught. Okay, so you don't need the length of the duct, or you don't need the height of the duct or anything. You just need the distance between the floor of the elevator to the ceiling, the height of the elevator's panel itself, or the elevator's chamber itself. That's the only thing you need, and that is given to you as 6 meters. Okay, so there's a person standing inside the elevator, and he observes that a screw comes off from the ceiling while the elevator was in downward motion with a uniform acceleration. So it's in descent at a uniform acceleration of 4 meters per second square. So he then observes, okay, that this falls from the ceiling to the ground. So what is the time taken for this screw to fall from ceiling to ground? And the second thing is, so what is happening with respect to ground frame? So imagine there's a person outside. So in his frame, what is happening? By the time the screw comes on the ground of the elevator itself is moved. Okay. So if this started at some t equal to 0, the screw starts from here. At some different time, the screw reaches here on the floor. But by then the elevators also made a downward displacement. So the actual downward displacement of the screw is not going to be h, which is 6 meters. It's going to be more than that, because during that time the elevator has also fallen down. So that is the second part of the question which you have to calculate. So work this out quickly and tell me the time taken for the screw to fall to the floor and the total displacement in the ground frame. Yes, for students who just joined in, you should have a pen and paper in front of you, and you should be writing down the class notes. You don't need to write everything in that much detail, but the working you should do yourself. Okay? I'll be sending you this notes later on PDF, but you should also be working yourself. So has anybody got the answer to the first part? Yes, in this situation, Parva, correct, distance and displacement will be the same thing. Yeah, Adinath, after your answer is correct for the first part. Is correct for the first part. Do Ahuja, correct. Very good. You also got the answer correct. Anybody else? Bhomik? You got the answer of the first part? Jeet, you'll have to check your calculation again. Okay, so let me give the others a bit of hint over here, how we can use relative motion very easily to solve this problem. So while the elevator is descending, so during that period of time, at some general time t, when the screw is somewhere over here, it has a downward acceleration of g, whereas the elevator itself has a downward acceleration of e0. Okay. So let us look at the motion from the point of view of the observer who's inside the elevator. So if you think about it, motion of the screw S relative to the observer E inside the elevator. Let's understand how that happens. So what that observer sees is what is the acceleration of the screw with the concept of relative. Yes, you guys, that's correct. It will be 6 because the acceleration of the screw is 10 meters per second square or g downwards in ground. And the acceleration of E is nothing but 4 meters per second square or E0 downwards in ground frame. So next thing we understand here is acceleration of the screw as seen by E will become acceleration of the screw in ground frame minus acceleration of E downwards. Okay. So that will become 6 meters per second square downwards. So this is what this guy is seeing. So going back to the diagram above, you'll see that to this guy, it looks like it's not going with G. Okay, to this guy, or the observer E, in fact, it looks like this is going down with an acceleration which is equal to 6 meters per second at some general time. Now, when it started from somewhere here, let's say, at t equal to 0. And by the time its motion is completed, to him, it will look like it's fallen freely all the way and reached here, let's say, time capital T, let's say, which we have to calculate. Okay. So once again, you can see in terms of relative motion, it's very easy to understand that also at t equal to 0, when the screw just comes off from the ceiling, at that moment, the initial velocity of the screw with respect to E will be 0. Okay. Why? Because the screw was fixed on the ceiling. Okay. So as it comes off, it starts from rest with respect to the ceiling. And the ceiling is basically the elevator frame. Okay. So therefore, E is frame. So the ceiling and the elevator frame are one and the same. Okay. So that's why this initial velocity of the screw with respect to E is 0, whereas the acceleration is 6 meters per second squared downwards. Okay. And in time t equal to 0 to capital T, okay, with respect to E, the screw falls through the entire height of the screw. Displacement of the screw with respect to T is going to be h downwards, or 6 meters downwards. So now you use this equation that displacement is equal to ut plus half at square in general. Whenever you have uniform acceleration. So here we convert it to a relative motion equation. So we say that relative displacement of the screw with respect to E is initial velocity of the screw with respect to E into time. So this is uniformly accelerated relative motion. And next, all you do is you substitute the values. So this is 6 meters, 0 plus half into 6 into capital T square. You'll get the time as 1 second. Okay. So just go through this entire solution. I'll give you enough time to note it down and everything. And then we'll come to the second part. And I'll just check the messages of those who have sent me the second part's answer and verify it for you. No, Dhruv. 2 meters is not correct because you see, it has to be greater than the length of the elevator. The length of the elevator is 3 meters. Okay, so ground frame, if you go back to the earlier diagram I had made for you, you'll understand that it has to be more than 6 meters. Yes. I'm like leaving this for you to write down. So this is the beginning of the first part solution. So this is the motion of this relative to this. Okay, so start writing down this part, then I will explain further. So here we are using the equation of relative motion. So the equations of relative motion are like this, that if one thing is going down with an acceleration of 10 meters per second square and another thing is going in the same direction downwards but an acceleration of acceleration of E naught. So that's the concept we've used over here, that if the screw is going down at G equal to 10 and the observer E, who's seen the screw beside him, he is going down with an acceleration of E naught equal to 6. Then the acceleration of the screw relative to the observer E will become 10 minus 6 or whatever, 10 minus 4. Six meters. So this is the calculation that we've done over here. Yeah, Advait, I'm explaining how the acceleration of the screw will become 6 meters per second square. Just a second. There is a small calculation thing that we do. Yeah. So this will not be 1 second. My mistake. This time will become root 2 seconds. T will become root 2 or approximately 1.41 second. Okay. Now let me explain the logic of this. How the acceleration becomes like this. So this concept. So we'll come back to the solution. Don't worry. I'll give you time. But since many of you have not understood how this has come, okay, we'll understand it this way. Let's see. Let's understand the concept of relative acceleration again. Now, if I have two people, A and B, moving like this, such that suppose A has an acceleration of 1 meter per second square, but B has an acceleration of 4 meters per second square. Okay. Then, what is the acceleration of B as seen by E? This is a concept of relative acceleration. This is acceleration of B as, or you can say relative to E. Yes, correct. The answer to that becomes that it is acceleration of B minus acceleration of B. So that becomes 4 minus 1, which is plus 3. So now you might ask that, okay, it seems logical, but where does this formula actually come from? This formula that I've written below. Let us understand where this formula comes from. So the formula actually comes from the idea of relative motion. The idea of relative motion is like this, that if on a particular axis, say the x-axis, I have two particles, E and B, okay, which are at individual coordinates xa and xb. Okay. So what is xa over here? It is the position of A with respect to the origin, and similarly xb is the position of B with respect to the origin. Okay. But now if I ask you, what is this thing? So this is the position of B relative to E. So back in the diagram, what is this thing? It is nothing but this thing. That in E's frame, where is the position of B is located? This is what will become the position of B with respect to the position of B. So that thing you can see is going to become xb minus x. Okay. So that is the most basic thing. Now, the moment you understand this, the rest of the things will follow from definitions. Okay. So you'll see now that suppose in a certain amount of time, what happens is, let's assume that now what happens is in a certain amount of time, both of them displace, and they displace such that A makes a displacement and reaches somewhere here, and B makes a displacement and reaches somewhere here. So A reaches the position A prime in some time delta t, and B also reaches the position B prime. So A has made a displacement of SA, B has made a displacement of SB in time delta t. Suppose A moves to A prime and B moves to B prime. Okay. So now we can see that what is the displacement of B with respect to A? So for that we understand what is displacement itself. So displacement is basically what? It is change in position. Okay. So displacement of B with respect to A will become what? Change in position of B with respect to position of A. So you substitute this only. Okay, so that is nothing but the change in the x coordinate of B minus the x coordinate of A. So that is nothing but change in xB minus change in x. So if you go back to the diagram, you will understand that what is the change in A's coordinate? It is nothing but A's individual displacement. A's x coordinate has changed from here to here, let's say xa prime. Okay, B's coordinate has changed from xB to xB prime. So ये change है xa से xa prime वो कितना है sa. ये जो change है xb से xb prime वो कितना है sb. So that is how. So that is why we are getting that this is equal to sp minus sc. So that becomes relative displacement. This becomes the formula for relative displacement. Okay. Now next is, suppose we understand the velocities with which they are moving. Okay. So we understand now that A is moving with some velocity v and B is moving with some velocity vb. Yeah, Ashul. This is very simple. This is algebraic. Displacement is defined as change in position. This is the meaning of displacement. This is from 1D motion. Okay. Displacement of a particle is nothing but the change in position in 1D motion. That is how we define displacement. Okay. So if you go back to the diagram here, okay, A's position has changed from here to here. So A's displacement is, it is just this arrow from here to here. So that is basically what the final coordinate minus the initial coordinate. Okay. So yeah, I mean, in a sense you can say it is distance, but it is with algebraic sign. So it will have either plus sign or minus sign. So that's why it's actually becoming a vector. Okay. Now similarly, B's individual displacement is how much? It is this. It is from xp to xp prime. Okay. So just as a numerical example, but before that, let's understand. So we are defining displacement as what? Change in position. So relative displacement क्या हो जाएगा? Change in relative position. So relative position in the earlier formula you have seen is xb minus xa. So displacement of B with respect to A will become what? It will become the change in x of B with respect to A. So that will be nothing but the change in xb minus xa. So it will become the change in B's coordinate minus the change in A's coordinate, which is nothing but the displacement of B minus the displacement of A. Okay. So let's follow this up with an example. You will understand this better. So suppose at t equal to 0, A was located here and B was located here. Now at t equal to, let us say, 3 seconds, A makes a displacement SA of plus 2 centimeters, and similarly B makes a displacement of plus 5 centimeters. Okay. So we want to find the new positions xa prime and xb prime of A and B at t equal to 3 seconds. Okay. And we have to find this quantity. The displacement of B relative to A. So let's think of this as a more basic example. Then we'll come back to the question we were doing earlier today. So just work this out with you. Yeah, Advait, I'll come to that. Okay. How we'll relate the distance ultimately. So what will happen in this question is that in 3 seconds A is reached here. So to what position? Is moved by 2 centimeters. So it's reached 7 centimeters. Okay. And B has moved somewhere here, let's say. To XB equal to 20 centimeters. Okay. Yes. So the answer to this part becomes yes. That's right. So now you can see what about the displacement of B with respect to A. So how you'll understand the displacement is, see in the first diagram, where was B related to A? How far was B from A in the first diagram? It was this. Okay. The distance between them was 10 centimeters. But now by the time this time, so this was the position between them. Okay. So from this you can see that the position of B with respect to A at t equal to 0 was plus 10 centimeters. Okay. But at the new time, what is the position become of A with respect to B? They change to this here. And this is how much it is, 20 minus 7. So that's how much, 13 centimeters. So x of B with respect to A has changed to 13 centimeters in time 3 seconds. Okay. So therefore, what is the displacement? It is 3 centimeters. Okay. But you can also understand this way, that the displacement of A with respect to ground was plus 2. The displacement of B with respect to ground was plus 5. So the relative displacement of B with respect to A should become how much? It should become plus 3. So this is another way of understanding the same thing. So that is how we get this formula, that displacement of B with respect to A is the actual displacement of B in the ground frame minus the displacement of B in the ground. And remember, here we are talking about 1D motion, so displacement and all are vector quantities. The direction is given by sign plus minus. No, so Varun, Aparna and V, that is why the displacement is not 13 centimeters beta. Displacement is the change in position. Have you understood my point now? Arshul, got it, understood this? So क्या हुआ है, A के रिस्पेक्ट में B has moved only 3 centimeters. It has not moved 13 centimeters because पहले तो 10 centimeter पे था ना. So B, so imagine let's imagine A is a car and B is another car. So sitting inside the car A, B was already 10 centimeters away. Now it's gone from 10 to what? 13. So the displacement for U has become how much? 3. Whereas actually in the ground frame, B is displaced by how much? It is displaced by 5. So that is the concept. Okay. Good. So now let us, from this concept next, let us understand relative velocity and then relative acceleration. So we can come back to the question we were discussing. Okay. So now, as far as relative velocity and acceleration is concerned, so let's talk about relative velocity. So in 1D motion in general, without getting into calculus and all that, I'm just saying, how do we define velocity? It is rate of change of position with respect to time. So we can say instantaneous velocity is delta x by delta t, as long as my delta t is small. Okay, this is how we define instantaneous. Whereas average velocity becomes total displacement upon total time. So like that, now how I will define relative velocity? Relative velocity of B with respect to A is nothing but rate of change of B's displacement with respect to time, as seen by E. So next you bring in that same definition, okay, that delta x B with respect to A is nothing but delta x B minus delta x A. So velocity of B with respect to A becomes so we can write it as delta of xb divided by delta t minus delta of xa divided by delta t. So that is nothing but VB minus V. So this gives us this very important formula that relative velocity of B with respect to A is velocity of B in the ground frame minus velocity of A in the ground frame. And there are countless examples in everyday life which you can relate with this. You can understand this. Okay. So especially those of you who joined in today, just make a quick note of this. Okay, people. So hope this concept is clear to all of you now. Delta is change. Delta is the change in some quantity. Now, final minus initial. Delta x, we say, is final value of x minus initial value. Okay. All right. So let us see this in a quick application first. So now this is that everyday situation which you experience. Okay. Let us say in one case, this is going at 40 kilometers per hour, and this is going in the same direction at 60 kilometers per hour. So what is the relative velocity of B with respect to A? It becomes how much? Plus 20. All right. Whereas now, imagine a situation where we have this, the same two things A and B, but they are coming at each other at these speeds. So now how we calculate velocity of B with respect to A? So for this, you have to be a little more careful. You have to understand that there is sign convention involved. So if I'm taking this as my positive x-axis, velocity of A will be given with positive sign. But velocity of B, yes, will be given with negative sign. So when you apply the formula, VB minus VA will actually become minus 60 minus of plus 40. So with the proper sign, it is in fact minus 100 kilometers per hour. So what does the sign tell me? It tells me that sitting in the car E, B's velocity looks like what? It looks like it's in the negative direction at 100. So the information this is giving me is what? It is the velocity of B with respect to B. So that means you are sitting inside the car A. So to you, A is not moving, but to you, B is moving towards you at how much velocity? At the relative velocity. Its direction is backwards. That is what the sign is showing. But its magnitude is how much? It's 100 kilometers per hour. And that's why we are saying over here that we deal with velocity. Right? So it's a vector quantity. So the algebraic sign plus minus is giving me this thing. Okay. So hope this concept is clear over here. Okay. And now from this beta, we come back to our final thing, which is acceleration. So if the two bodies are having some acceleration, we can calculate relative acceleration. So relative acceleration kaise aayega? Once again, we compare with 1D motion of a single particle. In 1D motion, we define acceleration as what? The rate of change of velocity with respect to time. Change in velocity upon change in time. So here, relative acceleration will be defined as what? It will be defined as rate of change of relative velocity with respect to time. Okay. So that becomes delta of VB minus VA, because that's what relative velocity was, divided by time. So that is delta VA by delta T minus delta VB by delta T, which is the absolute acceleration of V. This one is E. So this is the absolute acceleration of V in the ground frame minus the absolute acceleration of E in the ground frame. This is the relative acceleration of V with respect to this is relative acceleration of V with respect to E. Okay, so this is what we are going to apply when we discuss the solution of that question again. Yes, Bhaumik, it is a quick revision of last class. Okay, I know it will be a little bit trying your patience to go through this again, but just treat it like a quick revision. Now we'll come back to that question and you'll understand the whole thing. Harshul, to answer your question, why we have taken the velocity of V as minus 60 is because remember velocity is a vector quantity. So the direction is specified by the algebraic sign. You can see, मैंने क्या किया है अपने x-axis को I've taken towards the right. In this example, I've taken the x-axis towards the right, and V is actually moving towards the left. So that's why V's velocity should be given with a negative sign over here. Whereas E is moving towards the right, so its velocity is given with a positive sign. Understood? Whereas in this example, if we are taking VA as plus 40, then we should take VB also as plus 60. So that is why V of B with respect to A is becoming plus 60 minus of plus 40. Plus 20. But in this example, it becomes minus 100. Okay, now we are taking this relative velocity formula one step ahead. So we've got the formula of velocity of V with respect to A is velocity of V minus velocity of A. Now in this formula, we are now applying the rate of change concept to get relative acceleration. So our next thing, which is relative acceleration, is that formula, but that formula applied for rate of change. This one. Okay. So don't worry about the examples above and on that. I will send you the whiteboard notes so you'll get this. Now let's come back to our earlier question. So what is happening in our earlier question is very interesting. I'll explain the question from two points of view. Okay. So our earlier problem, one is think of the motion as seen by the observer who's inside the lift. What does this person A see? He sees that the screw comes off at t equal to 0. And after some time, it hits the floor. Okay. So this is the motion of the screw as seen by E, who is the observer inside the elevator. Whereas now also visualize what is the motion of this as seen by an observer outside. Imagine this is one of those glass bubble elevators, so you can see very clearly. So now let us say there's an observer B who's on the ground. This guy is a stationary observer. On the ground. So for him, what is happening? The screw is coming off from here at t equal to 0. Okay. And at some other time, by that time the elevator has reached somewhere here. It's hit the floor. Okay. So in his frame, this is the displacement. Okay. So this is the motion of the screw as seen by B, who is the stationary observer on the ground. Okay. Parva, to answer your question, you don't have to write everything down. have to just do the questions which I'm asking you when I give you the time to do it. That you do in your notebook. Whereas the rest of the things which I'm showing over here, which I am writing down for you, that I will send you the PDF notes. So don't worry about it. Okay? I'll send you these notes, and then you can write them down in your own language if you want. In the class, let's save time. Okay, so now what is happening is, you can see they're two totally different things. Okay, so what happens is, now let's come back. For the observer A, what is happening? The acceleration of the screw with respect to the observer A is how much? It is plus 6 meters per second square downwards. I can take it as plus because I'm taking downward direction as positive. Okay. I'm taking the sign convention that for me downward is my positive axis, positive x-axis. Okay. So how I've got this? So how I've got this is like this, that the observer A himself is fixed to the elevator. No? So he is coming down with an acceleration of 4 meters per second square. Whereas as the screw is falling inside the elevator, the screw is coming down with how much acceleration? It's coming down with g. Okay. So acceleration of the screw is equal to g, or 10 meters per second square downwards. Okay. Acceleration of the observer A is a naught, or 4 meters per second square downwards. So from this data, I'm getting this. This is with respect to ground. Okay. So this becomes the acceleration of the screw. Okay. So this is the acceleration of the screw as seen by the observer. Okay. Is this point clear to all of you? Okay. So if this is the case, now also what is happening? For the observer A, what is the initial velocity with which the screw is falling? It's 0. Because for him, see what is happening, in his frame the ceiling is not moving. So the screw starts from here with an initial velocity in his frame to be 0, but with a downward acceleration. With a downward acceleration of 6 meters per second. Okay. And then it goes and crashes against the floor at another time. So at some t equal to capital T, let's say, which we don't know, it's hit the floor. But we know that with respect to him, it's moved through a height of how much? 6 meters. Okay. Understood? So how will we write the equations of motion? The equation of motion of the screw S in A's frame, or relative to A. Okay. So the initial velocity is 0. The acceleration is 6 meters per second square, and the displacement we can see is 6 meters. The time capital T we have to find. This is it. Okay. So now we use our equation of motion. So displacement is equal to ut, which is 0, plus half at square. So I made a mistake earlier. I had taken t as 2 seconds, but here t will become root 2, or approximately 1.4 seconds. So what happens here is, he observes the screw falling through 6 meters, okay, ceiling to floor, in approximately 1.4 seconds. This is the motion as seen by this line. Okay. So the time is this much. Okay, so now people, you can write down this part of it. Okay. Start by understanding how we got the acceleration of the screw as seen by A to be 6 meters per second square downwards, and then how we solve for time. So just go through this, write down the final formula if you like and the answer, and discuss with me if you have any doubt. Yeah, I should just go through this diagram and this equations again and tell me. So A जो है ना एलिवेटर के अंदर है, तो उसके रिस्पेक्ट में उसका एक्सेलरेशन कितना हो रहा है, 6 मीटर्स पर सेकंड स्क्वायर हो रहा है, और उसके रिस्पेक्ट में वो कितना, how much it is falling to the actual length of the elevator, no, which is this one. Yeah, we can write root 2, no problem. We can write the answer as root 2. It's approximately 1.4 seconds. Okay. So again, imagine you are standing inside the elevator. So what you will see the screw coming down from ceiling to floor. So it's coming down to a height of 6 meters only in your frame. Okay. But in your frame, its acceleration will not be 10 because you yourself are going down at 4. No? The screw is actually coming down at 10, but your own acceleration is 4. So to you, it will look like the bolt is coming down only at 6 meters per second square. Hence this final equation over here. Hence this final equation, S is equal to ut plus half at square. But isme what acceleration we have to take? We have to take the relative acceleration. What initial velocity we have to take? We have to take the relative initial velocity. The relative initial velocity was 0. The relative, this thing is, acceleration is 6. So the relative displacement is 6 meters. Okay, Harshul, is it clear now? Okay, very good. Right, so all of you are clear with this part, how we got the time? Okay, that's good, no problem. Okay. Now, who has got the second part's answer? Bhaumik, have you calculated the second part's answer? Anyone else? Okay. So the second part of the question, I'll just repeat the question. Second part was find the displacement of the screw relative with respect to ground in this time. Okay, that is 0 to capital T, which we have actually worked out now to be root 2 seconds. No, Dhruv, it is a little more than that. Okay, it's a little more than that. Okay, so I'm just minimizing this so that you can see the last part also and use the data from that. Okay. Now, in this, one more thing was given to us. Okay. It was given that the initial velocity of the elevator was 2 meters per second at t equal to 0, 2 meters per second downwards. Okay. At the instant the screw came off. But understand one thing, this initial velocity doesn't affect my last part, because in the frame of the elevator, the initial velocity of the screw will be 0. Okay. So use the data from here and solve this part. Yes, you have to take the time as the free fall time of the bolt from the time it comes loose from the ceiling to it hits the floor is root 2 seconds. वो तो कोई भी observer हो, ground frame में हो या elevator के अंदर हो, both the observers A and B will see the same amount of time, but they'll see different amount of displacement. You made some typing mistake, I think. Yes. Okay, so let us see the final solution. So now you see what is happening from the point of view of the observer who's outside this frame. So t equal to 0. Both the bolt and the elevator have an initial velocity of 2 meters per second minus downwards. And of course, the elevator has an acceleration, but that doesn't matter. So for this observer B who's on the ground, he sees the acceleration of the bolt as how much? G. So acceleration of the screw in ground frame is nothing but G or 10 meters per second square downwards. Okay. And initial velocity of the screw is the same as the initial velocity of the elevator, which is 2 meters per second downwards. Okay. So now by the time it hits the floor of the elevator, let's say now this is the situation. This is at t equal to capital T. The bolt has fallen freely and reached here. This is at t. Okay. So this total will be the displacement. This will be the displacement of the screw in the ground frame. Okay. So the displacement of the screw in the ground frame will be what? Initial velocity into time plus half acceleration into t square. Okay. So this will become 2 into root 2 plus half into 10 into root 2 ka whole square. So the displacement of the screw in the ground frame will be 2 root 2 plus 10 meters, or approximately 12.8 meters. I'm taking root 2 as 1.4. This will be the displacement of the screw downwards. Okay. Now, before you note down this, see another interesting thing. In the same ground frame, what if we talk about the displacement of the elevator? How much the elevator has moved? So you can see that the displacement of the elevator that will be how much? It will be initial velocity of the elevator plus half E naught T square, because the acceleration of the elevator was E naught. So it will become 2 into root 2 plus half into 4 into root 2 square. So you can see this will become 2 root 2 plus 4 meters downwards, or approximately 6.8 meters downwards. This will be the displacement of the elevator. So from this also we can see that the displacement of the screw relative to the elevator should be equal to displacement of the screw minus displacement of the elevator, and that will come out to be 6 meters downwards. And this was as seen by the observer E, because he was inside the elevator. E here stands for the elevator. So that verifies what we have done in the first part. Since that verifies. So in this diagram, what is happening is that jitni der mein the elevator is coming from here to here. Okay. So the displacement of the elevator you can see is this much. This is 6.8 meters. But utni der mein where the screw has reached, it's reached here. So the displacement of the screw is 6.8 plus 6, or 12.8 meters. This is the displacement of the screw. This is the displacement of the elevator. Okay. So that's what we are observing after computing our calculation. Okay. Why we took acceleration as 10 meters? Because see, the screw is actually free from the elevator. Na? So its motion is free fall under gravity. Is there any other force acting on the screw? No, it's only gravity acting. So it will have an acceleration which is equal to acceleration due to gravity. वो तो elevator के अंदर जो है, to him it is looking like less than that because he himself is having a downward acceleration of 4. Okay, but actually the screw is doing what? It is in free fall. Actually it is falling with 10 meters per second square. It is only to the observer inside the elevator it seems less than this thing. Okay, because okay, Harshul, don't worry. If your phone got switched off or your internet connection went off, now you will get a video recording of this lecture, so you can understand this part again. U2 was given to us. In the question I had given, the initial velocity was 2 meters per second. That was explained in the question. Okay, that assume the initial velocity. So for the second part, it was given that assume initial velocity when the screw comes off is 2 meters per second downwards. Okay, is this completely clear, people? Okay, very good. All right, so now let us move on. Nee, G, it will not be 2 root 2 plus 6. It will be 2 root 2 plus 10 only. Because in the ground frame, its acceleration is this thing, 10 meters per second square. And to the person inside the elevator, there is no 2 root 2. It is just half into 6 into t square. Okay. Why there is no 2 root 2? Because for the person inside the elevator, the screw doesn't come off with initial velocity. It comes off at rest. It just comes off the ceiling. Na? So uske liye ceiling stationary hai na? So the object is also stationary. So for observer A, the initial velocity is 0 and the acceleration is 6. Whereas for observer B who's on the ground, the initial velocity is how much? Same as the velocity of the elevator at that time, na? Because it was stuck to the elevator. It's having the same velocity that the elevator has. So when it's just coming off, it's still stuck to the ceiling of the elevator. So uska velocity kitna hai? Ceiling ka jitna velocity, which is 2 meters per second downwards. But from there, it loses contact with the ceiling. So from there onwards, its acceleration becomes 10. Harshul, why 2 is it's given in the question? That's part of the data which is given in the question. 2 data are given to us in the question. In fact, 3 data. The acceleration of the elevator, which is 4 meters per second square. The initial velocity, which is 2, and the height of the elevator, which was 6 meters. So it's based on these 3 data which is given. Initial velocity kuch aur hota, we would have substituted it accordingly. Have you understood now? Okay. Now let us do another interesting question using the relative acceleration concept or relative motion concept rather. So next example is like this. We have, let's say, an absolutely straight canal with water flowing at uniform velocity. So the water inside the canal is flowing without any acceleration. So this is let's say 1 meter per second. Now, in this we have that's a raft floating on the water. Now, we also have M. Now a motorboat, okay, going downstream overtakes the raft. So M is that motorboat. At time t equal to 0. So at time t equal to 0, this motorboat is actually going to overtake this raft. Now, assume the motorboat has a uniform speed with respect to water of 5 meters per second. So find the velocities of the raft R and motorboat M as seen by a stationary observer on the bank, and find the velocity of the motorboat as seen by the raft. So start with these two parts, then we'll do more in this question. So take down this question, take down this much. No, see, the thing is, here what is happening, the motorboat's velocity, okay, first take down the question. Acceleration is 0 because everything is at uniform, a uniform speed of this much, and the water is also flowing at a uniform rate. So there's no acceleration involved. But the thing you have to understand is, ये जो data दिया हुआ है, this one, this is basically what it is, uniform speed with respect to water. You get this. So this is velocity of the motorboat with respect to the water is equal to 5 meters per second downstream. But what about the velocity of the water itself? That is equal to 1 meter per second downstream. So therefore, what about the velocity of the motorboat in ground frame? It will become this. Okay. So this is now a reversal of that equation. Relative velocity को कैसे लिखते हैं? By difference. So absolute velocity कैसे आ जाएगा? By sum. So this equation that I've written, it is actually just coming from this, that velocity of A with respect to B is velocity of A minus velocity of B. So now reverse this. So this becomes this. You understood now? So that is why now the solution to the first and second part will become like this. If I am taking my sign convention, just a minute. Switch on my battery. Yeah, sign convention is that suppose this direction is my positive axis. Then what is happening is, as the water is flowing like this, velocity of water as seen in the ground frame is plus 1 meters per second. Velocity of the boat with respect to water. Now the boat is moving like this. So that is equal to plus 5 meters per second. Therefore, velocity of the motorboat as seen in the ground frame, that will become this plus this. So it will become 6 meters per second. Is it clear? Another way you can think of it is like this, that imagine a man can walk at a speed of 5 meters per second. Okay. But now he starts walking on a treadmill, which itself is going at 1 meter per second. Now he starts walking on this at 5 meters per second. So uska net velocity क्या हो जाएगा? It will become the sum, right? It will become 6. So that kind of concept. Okay. Whereas the raft is floating on the water. Okay. So what velocity the raft has? Second part. The velocity of the raft is nothing but the velocity of water only, because the raft is floating. So that is equal to 1 meter per second. So now the velocity of the motorboat with respect to the raft is again 5 meters per second. Okay. So to the guy sitting in the raft, it will look like the motorboat is going past him only at 5 meters per second. It won't look like it's going past at 6. But to the guy who's standing on the bank of the river beside, to him it will look like the raft is going at 1 and the motorboat is going at 6. Understood? Is this clear to all of you? Exactly, that's correct. Okay. Now let's come to the actual interesting part of this question. So, are all of you clear with the first and second part? Any doubts in the first and second part, people? Okay. If anybody has a doubt, please send me a message in the first and second part. Good. Okay. Right. So, let's come to another interesting part of the question. So now what happens is, so third, okay, at t equal to 0, okay, the motorboat goes past the raft, okay, and at t equal to 20 seconds, it takes a U-turn and comes upstream, okay, crossing the raft again at t equal to capital T. Okay. Now in this, assume time taken to U-turn. To make the U-turn, the time taken is negligible. So we assume that the turn is completed in negligible amount of time. Okay. And the speed of the motorboat relative to water remains uniform at 5 meters per second, both upstream and downstream. So the boat always has a velocity, constant velocity of magnitude 5 meters per second relative to the water, whether it's going upstream or downstream. Okay. So now calculate the time capital D and D, where D is the distance covered by the raft in this time. Okay, so I'll take you through the question, but let me explain for diagram first. So what is happening here is at t equal to 0, the raft and the motorboat, they cross each other. Then as the motorboat keeps going, takes a U-turn. So this it does at 20 seconds. 20. At 20 seconds, takes a U-turn. And then comes like this. And by then, the raft has reached here. And the motorboat again crosses like this while the raft is moving like this. This is at some time capital T. Okay. And this distance is V. So these are the two things that we calculate. Okay. So understood the question, visually what's happening. So I'll just leave you with the data of the question. And now this is really interesting how you will solve this. Okay, so try this out. Okay, so use what you learned in the first and second part of the question. Use that information that you learned in the first and second part. That while the boat was going downstream, in ground frame the velocities of the boat and raft were 6 meters per second and 1 meter per second respectively. But relative to the raft, the boat was going at how much? 5 meters per second. So use that kind of data over here to understand what's happening. Yes, very good, Yuvraj. The answer is correct, 20 seconds. Okay. And therefore the distance will be here. Jeet, you just got double of the answer for some reason. Just check. Okay. And okay, so there are various different ways of doing this question. For example, suppose I want to understand the motion as seen by an observer on the ground. Okay. Suppose I want to understand the motion as seen by an observer on the ground. So what such an observer will be seeing is that, yes, Prapti, correct. Your answer is correct. So for an observer on the ground, we'll be seeing is that the motorboat, while going downstream, it had a velocity of 6 meters per second. Okay. And it went like this, took a U-turn. And then while coming back upstream, the motorboat will have how much velocity? It will have a velocity of 4 meters per second. Okay. While going down, it had okay. So the reason for that is, see, while going downstream, suppose we are using a sign convention, okay, wherein we are sticking to the same sign convention that this side is positive. Okay. So in the downstream journey, the velocity of the motorboat with respect to the water is +5 and the velocity of the water is +1. So the velocity of the motorboat becomes +6. Okay. But while coming upstream, your velocity of the boat with respect to the water is actually -5, because with respect to the water it is coming up at this much, whereas the velocity of the water is downward and 1 only, downstream and 1 only, +1. So what is the velocity of the boat with respect to the water? It becomes -4. This plus this. Okay. So this is what we have captured as V2 in the diagram, and this is what we have kept as V1. Okay. So this is what the observer from the ground frame point of view is looking at. Okay. So if you took the U-turn at t equal to 10 seconds, then this total displacement now is how much? From here to here, this displacement is, let's say, S1. So this is going to be how much? This is going to be V1 into T. So it's going to be 60 meters. So the boat will take a U-turn 60 meters from where it overtook the raft and come back. Okay. And then finally, let's say it reaches somewhere here, okay, when the raft is again moving. So this is at some time capital T. Okay. Whereas this was where the raft was initially. So this is always going at 1 meter per second. So this is still going at 1 meter per second. But now this is coming back at 4 meters per second. So this is where the raft is at that time capital T. Okay. So now you can see that in this diagram, this distance from here to here, which we have called small d, so that is equal to how much? 1 meter per second into t. That many meters. T is basically the velocity of the raft into the time. So that's 1 meter per second into that time, which you don't know yet. Whereas, what about this displacement over here? The second time round displacement of the boat from where it took the U-turn to where it's crossing the raft again. ये वाला displacement कितना होगा? Let's say this is S2 in magnitude. That is going to be how much? It's going to be 4t. So this is coming at 4. So is this clear to all of you? So let me take you through the diagram once more, so that is 100% clear. So what is happening is that this is where the motorboat is initially and the raft is initially. Okay. Yeah, I'm explaining again. So the raft is moving at 1 meter per second. The motorboat, while going downstream, is moving at 6 meters per second. Okay. This is t equal to 0. Then what happens? The motorboat goes all the way downstream and takes a U-turn at t equal to 10 seconds. So how far away it is when it's taking the U-turn, that is the main thing. So when it's taking the U-turn, this is all as seen by an observer on the ground. Okay, this is from the ground frame point of view. Okay, 60 meters, correct. Okay. So this is S1, let us say. So this is 6 into 10 or 60 meters upstream. Okay. Now what happens thereafter to the motorboat? Thereafter the motorboat is coming back like this, but with what velocity? With 4 meters per second. So when it crosses the raft again, let us say it's here, and now the raft is reached here. This is that middle to find out. So the raft is still going downstream at 1 meter per second, but the motorboat is now coming upstream at 4 meters per second. Is this part clear? Anybody has a doubt in the second part that why that speed is 4 meters per second? Have you understood? Oh, the initial time was 20 seconds. Yeah, just a minute. Let me check. Oh, sorry. Just make a correction here. We'll make this time because I've been solving for 10 seconds. So let's solve it for 10 only. We'll get a different answer. Make this t equal to 10 seconds. Make this 10 seconds. Suppose we make this 10 seconds. Then so now you can see that what is the displacement of the raft during this time. This is the displacement of the raft. So this displacement of the raft will be equal to what? The velocity of the raft into the total time. So it will become how much? T meters. Because the velocity of the raft was 1 meter per second. So here to here, this displacement is that much. It's 1 meter per second into t. But what about the displacement of the boat from here to here? What about this displacement? This is S2. This is happening at what velocity? 4 meters per second. But for how much time? For a time of t minus 10. Because here the time was capital T, na? But that's from t equal to 0. So upstream kitne time ke liye gaya hai? From 10 to capital T. So for how much time that velocity is upstream, it is t minus 10 seconds. So now in the diagram you can see that S1 equals the sum of the displacement of the raft plus the upward displacement of the boat. Okay. So that the downward displacement of the raft plus whatever magnitude it comes upward, okay, that difference should give you how much the boat has moved. Okay. So if this has gone down by S1 and then come up by S2, how much the raft has moved? It has moved by S1 minus S2 during that time. You understand? So that's the same equation as this. Okay. So now you just substitute and you'll get the answer. So S1, this equation is how much? It is 60 meters. Because I have taken the time as 10 seconds. If you take it as 20, it will just be 120. Doesn't matter. This should be equal to displacement of the raft, which was 1 meter per second multiplied by t seconds. Okay. Plus the upward displacement of the boat, which is 4 meters per second into t minus 10 seconds. Okay. So 60 is equal to t plus 4 into t minus 10. So you will see that you will get capital T as 20 seconds. Yeah, so I'm explaining this once again. So Harshul, it is clear to you that while going downstream, उसका velocity कितना होगा? 6 meters per second. Yes, this point is clear, Harshul. Right? Okay. And while coming upstream, boat का velocity कितना हो जाएगा? What I have taken the time as 10 seconds. हाँ, what 20 लिया होता तो हो जाता. I have changed the value, and the question I am taking it as 10 now. Take the value of time as 10 seconds. Okay. Yeah. So while coming upstream now, what will be the velocity of the boat? It will be 4 meters per second. Okay, Harshul. So 10 seconds ke liye it has gone downstream. So how far it has reached? It's reached a displacement of 60 meters. And then for some unknown time, let's say delta t, it's come upstream. So upstream it has come per second into that delta. Delta t is how much? Is the final time minus 10 seconds. This point is clear now? Okay. Now during that time, how much the raft has moved? The raft has moved from here to here. So during that capital T seconds, which we don't know right now how many seconds, the raft has moved with 1 meter per second for T seconds. So it's moved by T meters. So now in the diagram, you can see that the displacement of the raft is actually equal to the downward displacement of the boat minus the upward displacement of the boat. That's how they are meeting again. Na? So boat jitna niche gaya and then jitna upstream aaya. If I subtract the two, that is exactly the displacement of the raft. So that is this. The downward displacement of the raft is equal to the downward displacement of the boat minus how much distance the boat now comes upstream. So now you just equate this with the values. So what is the so this equation is the same as this. So what is S1? It was 6 meters per second into 10 seconds. S1 was 6 meters per second was the downstream velocity into 10 seconds. So that's how this was 60 meters. But what about the displacement of the raft during that time? It's a velocity of 1 meter per second into t seconds. Whereas the upward velocity displacement of the boat is not 4 into t, but it is 4 into delta t, where that much time it's going for upstream, which is how much? Total time minus 10 seconds. So this becomes a simple linear equation and you get the value of t as 20 seconds. Okay. So this is one way of solving the problem where we are solving it in the ground frame. So what we are doing is we are looking at the motions of the boat M and raft R as seen from ground frame. And you can also see that that distance d is nothing but displacement of the raft. So that is nothing but 1 meter per second into 20 seconds. So it's 20 meters. So both the parts are solved. You can see when the boat will again cross the raft, that will be exactly at t equal to 20 seconds. Okay. Now, if you had taken the U-turn time as 20 seconds instead of 10, you would have got capital T as 40 seconds. Okay, it will just come double. And you would have got this distance d also as 40 meters. Okay. But just change the value to 10 now, since I have done it using 10. Solve it this way. Right, this is clear to you? Fine, so take down this solution and now also solve this question by another method. Solve it by the motion of the raft relative to the, motion of the boat relative to the raft. Okay. Try to solve for time by trying to visualize if you're standing on the raft, you're standing stage to bank. Instead of our observer being here on the bank, if our observer was a person standing on the raft, then how would the motion of the boat look with respect to him? Try to solve it by that method. Okay, Dhyaneshwar, if that is the case, don't worry. You will get a video recorded version of the lecture later. Okay, so let me solve this from this point of view. So now imagine what is happening for the guy who's standing on the raft. From his point of view, when the motorboat goes past him, it goes with what velocity? So the velocity of the raft is the velocity of the water only. So it is plus 1 meter per second downstream. The velocity of the motorboat with respect to water is how much? It is plus 5 meters per second downstream. So that means what is the velocity of the motorboat as seen by the raft? It is plus 5 downstream. So in this situation at t equal to 0, to the guy on the raft, it looks like this is going downstream at 5 meters per second. Or you can also understand it this way, that we had seen the velocity of the motorboat in the ground frame was 6 and his own velocity is 1. So uske respect mein kitna ho jayega? 6 minus 1, 5. Understood this point? So another way to understand this is that with respect to the ground frame, the raft is going with a speed of 1 meter per second. With respect to the ground frame, the motorboat is going with a speed of 6. So the velocity of the raft is plus 1. Velocity of the motorboat is plus 6. So the relative velocity of the motorboat with respect to the raft is like this. Now what happens while he is coming back upstream? Now while coming upstream, what is the velocity of the motorboat with respect to the raft? This was downstream. Now while coming upstream, what will happen is the velocity of the raft continues to be plus 1. It is going like this. But the velocity of the motorboat in the ground frame was minus 4 in this direction. So what about the velocity of the motorboat with respect to the raft? It becomes minus 5. So that's the interesting thing. Iske respect mein, even while coming back, it has a speed of 5 meters per second. Okay. Actually, one time it was going downstream at 6 and he was going at 1. So to him, it looked like it was 6 minus 1. The second time it is coming upstream, they are going in opposite directions, but with speed of 1 and 4. So the relative velocity again becomes how much? 5. Is this point clear to all of you? So from that, okay. See, I'll explain again. What is happening is, in the downstream journey, during that time, what is the velocity of the raft? It is equal to plus 1 meter per second. Okay. Whereas what is the speed of the motorboat? It is plus 6 meters per second, like this. So therefore, in the raft's frame, what will be the velocity of the boat? It will be velocity of the boat minus the velocity of the raft. So it will be plus 5. Okay. Whereas when the boat is coming upstream, at that point of time, what is the velocity of the raft? It is 1 meter per second downstream. But what is the velocity of the boat now? It's like this. So with proper sign convention, we should write this as minus 4. Okay. So in this case, what is the velocity of the motorboat with respect to the raft? It is this minus this. So it becomes minus 5 meters per second. So how do you visualize this whole working now? You visualize it like this, that you are standing on the raft as an observer. So the motorboat goes past you at 5 meters per second at t equal to 0. Then it goes, takes a U-turn at t equal to 10 seconds and then starts coming back. But it starts coming back with what speed? Again 5 meters per second. when should it is going the same thing? They should obviously double of that. It should be 20 seconds. Okay. So that is the result. Is it clear now, Bhaumik? Yeah, Harshul, time came 20 seconds above by calculation. वो S1 को S2 plus displacement of the raft solved किया, so we got the value of capital T as 20 seconds. So it came by solving. Okay. No, because we are calculating, Parva, what we are doing is we are calculating the velocity of the boat with respect to the raft. So that is by definition velocity of the boat minus velocity of the raft. This was the relative motion definition. V of B with respect to A is VB minus V. It's not the other way around. When we had done the derivation earlier today, starting from the position, what is position of B with respect to A? It is the position of B minus the position of A. So on this, when we apply rate of change, so rate of change of this quantity is rate of change of this minus rate of change of this. So that's how we get this. Yeah, Bhaumik, I'm explaining the last part again. So are you clear with this part? While going downstream, the relative velocity of the boat with respect to the raft will be +5. This is clear? Okay. And this part is also clear. While coming back upstream, it is -5. Yes, Bhaumik, is this second part clear? Okay. Then the last part will be very easy. I'll explain. Just let everybody note down this part first. So don't worry about the solving of the last part. Just okay. Okay. So now come to it that with this data, कि जब वो डाउनस्ट्रीम जा रहा है तो उसको वेलोसिटी कैसा दिख रहा है? डाउनस्ट्रीम +5. जब वो वापस आ रहा है उसके तरफ उसको वेलोसिटी कैसा दिख रहा है? अपस्ट्रीम of 5 meters per second. So now think how the motion is looking. Just imagine you are standing on the raft. Now how does the motion of the boat look like? It goes past you and it goes downstream at 5 meters per second for 10 seconds. And then from wherever it's gone downstream, it's coming back to you at 5 meters per second. So in your frame, it will look like it has gone so many meters and come back the same number of meters. Na? तुम्हारे रिस्पेक्ट में उसका जो डाउनस्ट्रीम डिस्प्लेसमेंट है उसका अपस्ट्रीम डिस्प्लेसमेंट भी सेम होना चाहिए. So that is why the time should again be another 10 seconds. It's gone at 5 meters per second downstream and is coming back also at 5 meters per second. So if it's gone downstream for 10 seconds, it should come upstream also for 10 seconds. Okay. So I'll just explain this point here in more detail. You get it fully. So what happens is, therefore, in the raft's frame, okay, the boat overtakes and continues downstream at 5 meters per second for 10 seconds. Okay. So in the raft's frame, the motorboat was here at t equal to 0. It's going down at 5 meters per second and it goes downstream and reaches here at 10 seconds. Okay. So it's covered how much displacement. So the displacement of the motorboat with respect to the raft from 0 to 10 seconds is how much? 50 meters downstream. Okay. Now next what is happening? It's taking a U-turn, and after taking the U-turn, it's coming straight back towards it. But at what speed? So now it comes like this, again at a speed of 5 meters per second. So it comes like this, like this, like this, and finally reaches here at time capital T, if you want to find. Okay. So next, from t equal to 10 second to t equal to capital T, if you want to find out, the motorboat moves back towards the raft at 5 meters per second relative to it. So how much time it should take? Therefore, time taken and delta t, which you can write as t minus 10 seconds, should be the distance it is coming upstream. Okay, so that is 50 meters divided by the speed at which it is coming. So you can see that t minus 10 is also 10, or capital T is 20 seconds. Or just think logically, something is running away from you at 5 meters per second, and then 10 seconds later it's running back towards you at the same speed, 5 meters per second. So how much time it will take to come back to you? The same time it took to go away from you, because the speed is remaining constant. So that is what the guy on the raft sees. Okay, this is what the person on the raft sees as far as the motion of this is concerned. Is it clear now, Bhaumik? Yes, people, have you understood this? Parva, Bhaumik, Arshul. Anybody has a doubt in this part now? Okay, good. Yeah, so Harshul, again explaining what's happening. While going downstream, the boat went past you at 5 meters per second. It went for 10 seconds, so it reached a displacement of 50 meters with respect to you. And then it came straight back towards you again at 5 meters per second. तो तुम्हारे रिस्पेक्ट में वो कितना वापस आ रहा है? 50 meters ही आ रहा है ना वापस. Okay, so that is the thing, na? So from 10 seconds, that is when it took the U-turn, till capital T, when it's come back, what is happening? It's moving towards you. You're standing on the raft. It's moving towards you at how much speed? 5 meters per second. For me, the raft has become stationary, no? Because I'm in the raft's frame. That's the idea. I'm not in the ground frame anymore. For me, the raft is stationary. And I'm observing. That's why I'm not seeing the boat moving at 6 meters per second while it's going past me. I'm seeing it moving at 5 because I'm standing on the raft. Similarly, when it's coming back, I'm not seeing its speed as 4. I'm seeing its speed as 5 because I'm actually moving at 1 towards it and it's moving towards me at 4. So in my frame, its velocity is becoming how much? 5. Okay. So to come back to this point now, it goes past me at 5, then takes a U-turn and comes back to me again at 5 meters per second. So the motion is symmetrical. Na? It's going away from me at 5 meters per second, coming back towards me again at 5 meters per second. So whatever time it took to go away from me through that distance of 50 meters, it will take the same time to come back to me through a distance of 50 meters. Okay, so 10 seconds it has to go away from me, and then as it's coming back, how much time it will take to reach me again? It will again take 10 seconds only. Because in my frame, it has gone away also at 5, it's coming back also at 5. Is it clear now? Okay. Avishi, don't worry. If you got disconnected, you will get the recording of this later today. Okay, so you'll have the recording accessible to you. Bombing is the last part clear now? Okay. See what is happening. Pay attention here, Bombing. You are standing on the raft. Okay. Now what do you see? The boat, with respect to you, is going at 5 meters per second. Okay. And keeps going for 10 seconds. And then it's coming back at 5 meters per second. So what the boat is doing, it's going like this and then coming back the same distance. And while going also, it was going at 5 meters per second. While coming also, it is coming at 5 meters per second. So shouldn't the time be symmetrical? अगर इसको जाने में 10 सेकंड लगा 0 to 10 seconds, तो आने में भी तो 10 सेकंड लगना चाहिए ना. So this should be 10 to 20 seconds. Okay, right. So that is this particular question. So a lot of interesting things can be solved using relative motion. Now, what I'd like you people to do is when you are revising this lesson today, again correlate the relative motion method that we got for 20 seconds time with respect to the first method we had done, where we had solved it by ground frame method. And when you correlate it this time, you will understand more. You will learn more about relative motion, and it will show you the interesting aspects about it. Okay, so we will finish the lecture here today, and next time we will continue ahead with more examples of relative motion. And as we look at more examples of relative motion next time, we will also start looking at two-dimensional motion. That is motion which is happening in a two-dimensional XY coordinate frame instead of along only one axis. We will not be using vector notation, but we'll just be using simple coordinate geometry kind of method to understand motion in two dimensions. And from there, eventually, we will look at things like projectile motion, and eventually we'll bring in vector analysis also. Okay? So that's it for today's lecture, people. And those of you who are given the test on Sunday, if you are having any doubts in any of the questions, you can please send it to me on WhatsApp. I'll help you out with the solution. Okay, that's it. Thank you, people. All the best. As I said, especially for the new people, I will send you the complete notes that I've discussed on the board here. So you get a copy of that. Plus, you will have a video recording of the lecture. So if you missed anything because of internet connectivity issues, you can see it in the video recording. Okay, thanks, and all the best, people. Stay safe.